This video looks at tree diagrams, and in this situation, Jack cycles or walks to school. And we know that the chance he cycles is 0.6. Now, because there are just two options, the chance he walks is 0.4. Now then, if he cycles, the chance he is late is 0.2. So the chance he is not late, or late complement, must be 0.8. Then if he walks, he is late with a chance of 0.3. But if he walks, then he is therefore not late with a chance of 0.7. The chance he is late depends upon whether he cycles or walks. We can then find the chance of each of the routes through the tree diagram. The chance of cycling and being late is then 0.6 times 0.2, which is 0.12. The chance of cycling and not being late, 0.6 times 0.8, 0.48. The chance of walking and being late, 0.4 times 0.3, also 0.12. And the chance of walking and not late, 0.4 times 0.7, 0.28. We then use these calculations to answer three questions. So the chance of being late, there are two options. Is either late having cycled or late having walked. So there's two options. So all we do is we add together the two possibilities to get 0.24. A nice simple start. Now the second question is a bit trickier. It's a conditional question. He walked given that he is late. So we know he is late. What's the chance that he walked to school? Now then, there's a formula for this, as follows. If I denote this by W and this by L, the chance walked given that he is late is walked and late over late. Now then, walked and late, that is 0.12. However, the chance of being late, we've already worked out, it was 0.24. There were those two options there. So therefore, it's 0.12 over 0.24, which is 0.5. So this is a key formula which you must learn. Part 3. Suppose that we want to find the chance he is on time 3 days out of 5. Well, this means that he must be on time, and then late and late. But there's all the combinations within that as well. He could be late for the first 2 days or for the middle 2 days. So, this is where we use the binomial distribution. So, out of 5 days, we want to be on time 3 times. Now, the chance of being late is 0.24. The chance of being on time is therefore 1 minus that, which is 0.76. And we want to be on time 3 times. Therefore, late twice. So therefore we put that into our calculator and then work out that the answer to that is 0.2522 significant figures. This video looks at how we can use tree diagrams to solve potentially quite complex problems in probability. Now suppose Sam's got a bias coin such that the chance of getting ahead is 3 out of 10, and he tosses this coin twice. So When he first tosses the coin, he could get either a head or a tail. And the chance of a head is 3/10, so therefore the chance of a tail will be 7/10. That's the first option, having tossed the coin once. He then tosses the coin for a second time. So it could be head then head, or head then tail then head, or tail then tail. It's the same coin, so therefore the individual fractions stay the same. Now then, we want to find the chance of getting a head and a tail in any order. So what we do is we look for the journeys through the tree diagram which satisfy the condition a head and a tail, or this head then tail, or this tail then head. And to find the chance of that occurring, we times together the fractions along the way. So this 3/10 times 7/10, which is 21 out of 100. Or this 7/10 times 3/10, which is also 21 out of 100. Because there were two different ways to get a head and a tail, we then add together those fractions to get the overall answer, which is 42 over 100, or 21 over 50. So the chance of getting a head and a tail is 21 out of 50. In this problem, Carolyn eats 2 biscuits from a tin, and the tin contains 20 biscuits, 12 plain, 5 chocolate, and 3 ginger biscuits. And the question is, what's the chance that they're both not the same type? Now, there's lots of ways to solve this, but one of the simplest ways, if unsure, is to use a tree diagram. Now, when she first takes a biscuit from the tin, it's either plain, chocolate, or ginger. Plain is 12 out of 20, chocolate is 5 out of 20, and ginger is 3 out of 20. So that's the first biscuit. But then she goes in for the second biscuit. So if she got a plain biscuit first, when she goes in for the second biscuit, there are only 11 plain left out of 19. There are still 5 chocolates and still 3 ginger. However, if she got a chocolate first, there are still 12 plain, but now there are 4 chocolate. And now there are still 3 ginger. But if she got a ginger first, there are still 12 plain, there are still 5 chocolate, but now there are 2 ginger. Now, the options which include not the same type are plain chocolate, plain ginger, chocolate plain, chocolate ginger, ginger plain, and ginger chocolate. So I must work out each of these by timesing together the fractions. So this one is 12 times 5 is 60, 60 over 380. This one is 12 times 3 is 36, so 36 over 380. 5 times 12 is 60, so 60 over 380. 5 times 3 is 15, so 15 over 380. 3 times 12 is 36 over 380, and 3 times 5 is 15 over 380. So I then just add together all the fractions. So just to check, we do this properly, 60 plus 36 plus 60 plus 15 plus 36 plus 15 gives me 222. So it's 222 all over 380. And that is the final answer, which might possibly cancel down 111 over 190. In part 1 we're told that there are 400 boys and 500 girls, and the probability of a boy being vegetarian is 0.1, and of a girl is 0.2. So the number of boys we'd expect to be vegetarian will be 0.1 lots of 400, which is 40. So we'd expect 40 boys to be vegetarian. Now the number of girls we'd expect to be vegetarian is 0.2 times 500. Well, 0.1 times 500 is 50, so 0.2 times 500 is 100. So therefore, we'd expect there to be 40 plus 100, which is 140 vegetarians in the school. In part 2, we're then told there are 10 prefects, 4 of whom are vegetarians. Now suppose 2 are chosen at random. What's the chance they are both vegetarian? Now to answer this, you might choose to do a quick tree diagram. So when we first pick our first prefect out, they could be vegetarian or not vegetarian. Now the chance for the first will be 4 out of 10 to be vegetarian. The chance they're not will be 6 out of 10. That's for the first prefect. When you pick your second prefect out, the numbers change slightly. If you pick vegetarian, there are only 3 left, so that will be 3 out of 9 for vegetarian, but there are still 6 left who are not, so that's 6 out of 9. If the first person was not vegetarian, there are still 4 vegetarians left out of 9, but only 5 left who are not vegetarian. So that's a quick tree diagram. So the chance that they are both vegetarian is that route there through the tree diagram. So we have to work out 4/10 times by 3/9. Well, 4 times 3 is 12, and 10 times 9 is 90. This will cancel down to 6 over 45, which cancels down further to 2 over 15. So the chance that both the prefects chosen are vegetarian is 2 out of 15. In this question there are 7 tiles in a bag. Jim pulls out 1 tile, which is not then replaced, and he then pulls out a second tile. And we're asked to solve 2 questions. What's the chance they are both 1? And what's the chance that the second tile is greater than the first? Now I think the best way to solve this is through a tree diagram. Now when Jim first pulls a tile out, the options are either 1, 2, or 3. The chance of a 1 is 2 out of 7. The chance of a 2 is 3/7, and a 3 is 2/7. He then goes in for a second time, and of course the process is repeated. So a tree diagram just lists concisely all the possible options. However, these events are dependent, because if he pulls a 1 out, there'll be 1 less 1 in the bag. So the chance of a 1 is now 1 out of 6. The chance of a 2 is 3 out of 6. And the chance of a 3 is 2 out of a 6. That's if he pulled a 1 out first. If he pulled a 2 out, it's then 2/6, 2/6, and 2/6. But if he pulled a 3 out, it's then 2/6, 3/6, 1/6. So this tree diagram lists all the options with each of the fractions labelled clearly above the branches. Now the chance that they are both 1 is this option here through the tree diagram. And to work this out, we just have to times together those 2 fractions. So we do 2/7
times by 1/6. 2 times 1 is 2 over 42, which is also 1 over 21. Now in part B, the question is, what's the chance the second tile is greater than the first? Now because we've drawn a tree diagram, we have to just tick all the options which satisfy this condition. Well, 2 is bigger than 1, 3 is bigger than 1, 3 is bigger than 2. So there's 3 options. So I must work out each of the options separately. So 2/7 times 3/6, which is 6 over 42. 3/7 times 2/6, which again is 6 over 42. And the other option is, I missed that one there for a second, 2/7 times 2/6, which is 4 over 42. So there's that option, and also that option there. And therefore, to answer the question, we just add together the 3 fractions. 6 plus 6 plus 4, we get 16 out of 42, or 8 over 21. So the chance the second tile is greater than the first is 8 over 21.
In this problem, Wendy plays 2 games at a fun fair. Hoopla, in which the chance she wins is 0.4, and a coconut shy, in which the chance she wins is 0.3. Now I can draw a tree diagram to represent this. Now the first 2 branches represent the hoopla game. Now she will win with a chance of 0.4. She will therefore lose with a chance of 0.6. So that's the hoopla game. She then goes on to play the coconut shy, which she could either win or lose. Win or lose. So this represents all the combinations. However, the chance she wins the coconut shy is 0.3, so the chance she loses is 0.7. 0.3, 0.7. And this set of branches, as I said, is a coconut shy. So this tree diagram is now completed. We've got the branches labelled win, lose, win, lose, win, lose, and we put the chance of winning or losing above or below the branches. So the chance that she wins both games is win, then win. And to work out the overall chance, we times together the 2 numbers. So the chance of winning both equals 0.4 times 0.3, which works out at 0.12. This video shows the different ways that Andy gets to work, depending on whether it's dry or it's wet. And we're asked to find the chance that the weather is wet and Andy goes by bus. Now on this tree diagram, wet and then by bus is that route through the tree diagram. So the chance of it being wet and Andy goes by bus equals 0.4 times by 0.7. So we times together the 2 probabilities, and that gives an answer of 0.28. This symbol here means and I've abbreviated dry, wet, walk, bike and bus using these shorthand abbreviations. Now part 2 asks for the chance that Andy walks or travels by bike. Now if we look down our tree diagram, that's walks, that's bike, that's walk, and that's bike. So we've got to find out each of these four options and then add them together. So we've got 0.6 times 0.5 plus 0.6 times 0.4 plus 0.4 times 0.2 plus 0.4 times 0.1. Just be on the safe side, we'll use a calculator. 0.6 times 0.5 plus 0.6 times 0.4 plus 0.4 times 0.2 plus 0.4 times 0.1, which gives an answer of 0.66. That's the chance that Andy walks or travels by bike. And that simply means or. Okay, now the final part of the question is a conditional question. The question says, what's the chance the weather is dry, which is D, given that Andy walks or travels by bike? Now the formula for this is the chance it is dry and he walks or takes a bike, all over the chance that he walks or takes a bike. Now this is not as confusing as it might appear, because dry and walks or bike just corresponds to the options where it's dry and he walks or takes a bike. So the top is just dry and walks or dry and bike. So the top is just 0.6 times 0.5. It's that option or it's that option. So dry and walks or dry and bike. All divided by walks or bike. And that was the calculation from part 2, which was 0.66. So I just enter that into my calculator. So 0.6 times 0.5 plus 0.6 times 0.4 is 0.54. So it's 0.54 over 0.66, which is 0.82 to 2 dp.